5, 4, 3, 2, 1.
Yeah, Germany confirmed release as well. And that's the object right there. I saw it blue right out, the big bright object on the screen, the brightest thing you can see, I think, isn't it?
It is. It's at left center.
Yeah.
About halfway between center and the left edge.
Roger.
Seems to be holding or shrinking.
712 over. Kit Peak, we have a comet. We have the comet. It is on tape. Over.
That's impressive as hell.
Well, we have it here, the tail is coming. The tail is coming up here towards the top. It's very faint here in this image, but it's there.
This vivid image was captured over the South Pacific. It was hoped that the comet would be visible for an hour, but after only 6 minutes, it vanished, blown away by the unpredictable speed of the solar wind. The behavior of the comet is important to understanding the impact of this powerful force on an invisible envelope around the Earth, the magnetosphere. Like the Sun, the Earth has a magnetic field believed to be the result of electrical currents generated deep in its core. When Earth's magnetic field interacts with the solar wind, it forms a shield. It also forms the shape of a comet. The magnetic field facing the Sun deflects the solar wind around the Earth. It bends the Earth's magnetic field into a tail that stretches 1,000,000 miles into space. The only visible manifestation of the solar wind ripples across the polar sky like an eerie veil, the aurora borealis. For more than 1,000 years, songs have been written to it, children named after it, poetry inspired by it. Rarely seen in Europe, the appearance of an aurora in 1570 is vividly chronicled in a medieval manuscript. The town was illuminated as if it were ablaze. When the people saw it, they were horrified and said that no such gruesome spectacle had ever been seen or heard of within living memory. Just 30 years ago, the upper atmosphere was inaccessible. Now an arsenal of scientific weapons stands ready to explore the mysterious aurora. "30 miles north of Fairbanks is a unique research facility, the University of Alaska's Poker Flat Research Range. When intense auroral activity is expected, preparations begin early. A 3-stage rocket is carefully moved to its launch pad for assembly. The procedure is time-consuming and can be dangerous. The payload is a 9-inch explosive charge. It will eject a tracer of barium into the aurora. The accuracy of the rocket is dependent on the wind and the weather. A balloon is released every hour to track minute changes in wind speed and direction. By nightfall, preparations are complete. Eugene Westcott of the University of Alaska will monitor the rocket launch and the barium release. If all goes well, one more chapter will be written in the search to understand the dynamics of this remarkable event.
By putting up a barium release, which is like a tracer, we like putting dye into a stream, we hope to understand more fully the electrodynamics of what's going on. If we're lucky, we'll see something that we've never seen before that'll give us a deeper understanding of really what's going on.
FAA, this is Poker Flat. We're at T-minus 5 minutes, and we'd like to pick up the count. Could I have clearance?
Westcott has been carefully monitoring the aurora. Now he will decide whether to proceed with the launch.
Okay, Pat, we'll go.
As the rocket intercepts the aurora, charged particles hit the barium to illuminate the night sky. 30 years of experiments like this have finally revealed the origin of the aurora. The solar wind acts like a generator. As it strikes the magnetosphere, it discharges billions of watts of electrical power. The energy flows down Earth's magnetic field lines toward the poles. As it hits the upper atmosphere, it begins to glow like a halo of fire to form the aurora, a permanent feature of Earth's atmosphere at both the north and south poles. Recently, a unique instrument, designed by the University of Iowa, was flown aboard a polar orbiting satellite, the Dynamics Explorer. The result, this breathtaking time-lapse image of the aurora borealis, seen from space for the first time. In another laboratory at Poker Flat, an even more dramatic experiment is underway. A system of extraordinary television cameras, sensitive enough to see the glow of a cigarette 5 miles away, will attempt to record tonight's aurora. Violent and elusive, it is difficult to capture. But Shun Akasofu and his associate, Dan Osborne, have perfected the technique. Television cameras are the latest tool for detecting the subtle features of an aurora. They also enable us to witness, in real time, the most dazzling light show the world has ever seen. Much has been learned about the aurora, but a key question remains. Exactly what happens when billions of watts of electrical power are pumped into Earth's atmosphere? In Boulder, Colorado, the Space Environment Service Center monitors the sun 24 hours a day, 365 days a year. When solar activity begins on the sun, time is critical. Warnings are immediately issued to the Department of Defense, NASA, and to airlines that fly the polar routes.
At this time, I would like to issue an alert for an X-ray event.
8 minutes after the eruption of a solar flare, a blast of X-rays and high-energy radiation tears into Earth's upper atmosphere.
We would expect protons to accompany this event within the next 48 hours.
Protons are accelerated by the solar wind. In hours, they will bombard the upper atmosphere to create a storm in the Earth's magnetic field. During a proton event, shortwave radio signals can be blacked out for days. Telephone circuits can experience overloads, and power stations a surge in electrical currents. Under the blanket of Earth's atmosphere, most of us are unaware of the potential dangers of solar activity. Like the people of the ancient world, we too worship the sun, each in our own personal way.
City and the valleys are peaking around 102. And now for the moment you've all been waiting for. Let's turn so you don't burn.
Unfortunately, we have recently discovered that the sun can be hazardous to our health. Excessive exposure to invisible ultraviolet radiation is the primary cause of skin cancer. 15 miles above Earth, the sun interacts with the atmosphere to create a protective shield called the ozone layer. Ozone protects us from most ultraviolet radiation. Although the sun steadily creates ozone, scientists have recently discovered that violent outbursts of solar activity can also destroy it. A scientist from the National Oceanographic and Atmospheric Administration witnessed just such an event. George Reed.
In August of 1972, we observed the most intense solar flare we've seen in the 30 years or so since we've been studying these events. For the first time, we could observe directly how these events can weaken our protective ozone layer by introducing nitric oxide, which is a powerful chemical destroyer of ozone.
At the University of Colorado, concern over this dramatic discovery has prompted a unique experiment. Students are manning a satellite, the Solar Mesosphere Explorer, launched by NASA in 1981.
We are now transmitting sensitive commands to the spacecraft.
A virtual laboratory in space, the satellite is monitoring changes in ultraviolet radiation and ozone. Early results from the satellite have confirmed the direct link between the destruction of ozone and the increases in nitric oxide produced by ultraviolet radiation. We now know that the ozone layer is far more delicate than we ever envisioned. The balance between its creation and destruction took billions of years to evolve. The question now is, can man destroy that delicate balance?
By changing the atmosphere through his industrial, agricultural, and chemical emissions, can we severely damage our protective blanket? How far can we go before the ozone layer is seriously depleted? How can we be sure of these things? These are questions to which scientists are only just beginning to find the answers.
A profound revelation of the 20th century is man's impact upon his global environment, one that may now touch upon his relationship to the sun itself. Still, the affairs of man are but an epilogue to the history of Earth. Billions of years ago, the sun cast its control over planet Earth, setting the stage for evolution. Only now are we beginning to grasp the full dimensions of its incredible power. For the first time, we have seen it from space, awed by its violence and imperfection. We have probed its surface, and beneath found infinite rhythms and subtleties that shake our confidence in its reliability. Our efforts to understand our own sun have taught us to see other stars differently. 1,500 light years from Earth, in the Orion Nebula, stars much like our own are being born, and with them the ingredients of living matter. The chemical elements of life have their origin in the living and dying of stars. Born to planet Earth, we are truly children of the sun. Our link to the stars was forged from the beginning of time.
Image, but it's there.
This vivid image was captured over the South Pacific. It was hoped that the comet would be visible for an hour, but after only 6 minutes, it vanished, blown away by the unpredictable speed.
5, 4, 3, 2, 1.
Yeah, Germany confirmed release as well. And that's the object right there, sun plume.
The solar wind. The behavior of the comet is important to understanding the impact of this powerful force on an invisible envelope around the Earth.
Kit Peak, we have a comet. We have the comet. It is on tape. Over.
That's impressive as hell.
Well, we have it here, the tail is coming. The tail is coming up here towards the top. It's very faint here in this.
Right on the big bright object on the screen, the brightest thing you can see, I think, isn't it?
It is. It's at left center.
Yeah.
About halfway between center and the left edge.
Roger.
Seems to be holding or shrinking.
712 over.